Yeah, I'm recording the screen. People are coming. Yeah. Great. I totally understand because I have the other workshop in Korean version, right? So I listen some voice from them, including you guys. I mean, as I said, the learning code takes time, basically.
Oh,
So
yeah.
it's almost impossible, like learning, one language during the 6-day or 5-day workshop. This is, I think, is impossible. But again, I'm trying to share my experience and knowledge based on some level of the engineering in terms of the computational design stuff. So maybe I'm not like a best guy in this area. So probably I made some mistake or I have some wrong idea, probably. So but at least we have some map, right, that we can trace. So maybe my workshop become like possibly a sort of helper to develop you guys like professional trajectory in terms of a computation design with the data. So again, as I said, I have on my YouTube channel. So there's always I upload my video on YouTube. So whenever you need, just access. And then on my Medium channel, there's the index. So if you have any question after this workshop about my material, please let me know. I'm happy to discuss and improve my material by myself. Because I'm also keep learning by interacting with other people in our area. So yeah, let's get started. So I'm going to share my screen. And then, most importantly, I think I can open my chatting here. Yeah, I'm getting used to using the Zoom. Okay, so today I am going to talk a little bit about computation and geometry and geometry class, particularly using TypeScript and visualization things. So as we did, we have three sort of research overview that I have been done before, and then little idea about the geometry or class things in TypeScript. And then we have a bunch of workshops as we did. Yeah, we need to create some mathematical geometry object today, and then try to visualize this object in a Canvas API. Okay. And as an additional note, I digging my GitHub a little bit, and then I found some of my class which is open to public. So I'm just trying to share the vector class and line and polyline. I think that there are different types of versions like C#, Python, JavaScript, and Java, I guess. But on the internet, there's a lot of good material describing vector or some geometric, analytic geometric things. So I would like to recommend like search and Google it. I think that, as I said, like as a computational designer or software engineer for graphics, most important abilities to find the information that you are looking for. As I said, as a developer, I'm always facing the problem. I need to debug them correctly. So I think this is important thing rather than just knowing some component or some API things. So great. Yeah, the first project is I already talked about these projects on my the lecture series, the first video, but we can simply revisit again here. So this is the project I did in the flux. Yeah, there's many people to engage in this project. So most of my job is to develop some like an algorithm to fit the parking lot in arbitrary boundary site in the Singapore. So the input, our client is a developer. They are really interested in, they have no idea about the design, but they're really interested in packing, the parking lot in the particular the boundary site. So we developed some algorithm. I did like 2016 there, but these days many people use shows similar like optimization things for their building or parking lot and things like that. And particularly in the Singapore, they have their own, I cannot remember, but they have some precast, like a modularized system. So based on this modularized system, we need to find like optimal best, the parking lot, like a configurator on the site. And on the other hand, also I open some parameters so that designer can see some level of the optimization. So for example, I want to see like the best options in that particular site. So I visualizing some combination of the parameter here, for example. So we can actually create our own sort of filter system so that we just visualizing based on the selection from the user or developer. So I mean, there's a lot of possibility in terms of the computation design with the optimization things. So I mean, all possibilities here. It's actually it's all about the the geometry optimization that we're gonna learn today. And then this is the second research I did. This is more about like optimization problem. So we have two different types of rule. One rule is we have a column to support our ceiling. And the ceilings actually need to follow, I mean, found the best place to support the ceiling. At the same time, we have a particle representing people. They try to push the column, and then the column is trying to looking for the place to support the ceiling. So as you can see, we have a multiple trial, like a iterative trial to find the like best the configuration in terms of the location of the column. Also, we have some other, let's say, limitation or like a some rule that we need to follow, for example. So there's some different circumstances, so such as we have a fixed situation, we have a void, the void space and solid space that people cannot penetrate. So this is very fun because we basically create the environment and then see how the computer, the algorithm found the best options. You know what, previously the parking lot is there will be one best option, but in this case we have a multiple option. So I think the computation design or like the optimization give us a way to find like a more possibility within some confinement. Correct. So let me jump. This is my thesis, Harvard GSD. At that time, I'm very, I mean, my thesis is more about like a prediction and training 3D geometry. There's a two part. One part is more about like how we, train a machine or network for the 3D geometry things. So there's a multiple way. I mean, even these days, there's a more like a brilliant way. But at that time, what I did is like a voxelize, and then using the pix-to-pix the network, which is a little bit famous right now. I mean, famous. So we basically train the data and then get the the result out of the training. And then as a second step, we try to sort of reconstruct the 3D geometry out of the prediction. And I mean, this is a very like let's say the common the machine learning and process, I guess. But at the end of the process, I'm trying to think about like how I ask a machine as a worker, as a creative, I don't know, some output. So what I did is at the time is I felt like the possibly error become creative for the machine. So I'm trying to make up as much as I'm trying to make an error as much as possible in order to get the what is the best error, that you can consider this as a creative way, right? So in order to do this, there's a multiple way, but one thing I can tell you is we have some linking system. So we have basically user can draw their own some sketch of the 3D geometry, and then the network gave us like some linking. Yeah, so we try to bind them like blend them and then create the new types of the geometry, which is sometimes weird, which is sometimes very brilliant, because that's something we never thought about it before. Yeah. So as I said, in this context, I try to understand what is the the creativeness in the machine learning, and then I assume that possibly error could be considered as the creativeness. Again, not error, but like a brilliant error, or like error something by chance. Yeah. I don't know. This is just my thought. I'm keep thinking right now. I'm keep learning new methodology, and I'm very big fan to learn new technology things. So if you guys have a better idea, we can talk in the different discussion.